Synthetic division. Synthetic division is a shortcut method for dividing polynomials. It focuses just on the coefficients and constant terms without having to worry about the variables. And it works best if the divisor is a linear polynomial, meaning that it has a degree of 1, and it has a coefficient of 1. So here's an example of a linear polynomial. We can see that the x doesn't have an exponent. That tells us that it's linear with a degree of 1, and the x also doesn't have a number written as the coefficient, so it's implied that the coefficient is 1. So here are some other examples: x minus 7 and x plus 12. Here's our example. We're dividing 4x cubed minus 9x plus 6 by x plus 2. The first polynomial is our dividend, and the second polynomial is our divisor. And notice that the divisor is a first-degree linear polynomial, and the x does not have a coefficient written there. So it's implied that the coefficient is 1, and this satisfies the conditions for us to be able to use synthetic division. Okay. Before we set up the problem, we need to make sure that the terms in each polynomial are written from highest degree to lowest degree. So if we look at the dividend there, the first term is a third-degree term. It has an exponent of 3. The next term is a first-degree term, and the last term is a constant term. So it does go in order from highest to lowest degree. And in the divisor, we start off with the first-degree term, which is the x, and then we have the constant term. So that's written from highest to lowest degree terms as well. So we don't need to make any changes there. Okay. And if we have any missing terms, we need to fill them in with a 0. The dividend there does not have an x squared term. It's missing that second degree term. So when we get to setting up the problem and writing in the numbers, we're going to need to fill in a 0 for that missing term. Okay. Next, we can draw an L-shaped bracket. Notice that this symbol is different than the symbol that's used for long division. Now that we have the bracket set up, we can begin filling in the numbers. We're going to write the coefficients and constant term of the dividend inside the bracket. The coefficient of the third-degree term is a 4, and we didn't have a second-degree term in this polynomial, so we're going to fill that in with a 0 once we get to it. Our first-degree term has a coefficient of 9, but since we have subtraction in front of it, we'll treat it as negative 9. And then our constant term is a positive 6. So we write each of those numbers in. Remember that since we didn't have a second degree term, we fill it in with a 0. Now we can write the constant term of the divisor in front of the bracket, and we need to use the opposite sign of that term. So our constant term is a positive 2. We're going to change it to the opposite sign, which would make it a negative 2, and we write it in front. So here's what our synthetic division problem will look like when it's set up. Remember that the coefficients and constant term from the dividend go inside the bracket. The constant term of the divisor goes outside of the bracket, and we need to change the sign. And then once we're finished solving the problem, the coefficients of our quotient or solution will be at the bottom there. Okay, so let's begin to solve this problem. First, we need to bring down the first number of the dividend, which is the 4. Just write that down below the bracket. Next, we're going to multiply the negative 2 times 4, which gives us negative 8. And we write that in the second row in the bracket. And then we're going to add the 0 and negative 8 together, which gives us negative 8. And then we're going to repeat those steps. We're going to keep multiplying and adding until we've worked our way through the whole problem. Okay, now we multiply the negative 2 times negative 8, gives us positive 16. Add the negative 9 and 16, gives us 7. And then multiply negative 2 times 7, get negative 14. And then add the 6 and negative 14, we get negative 8. Okay. So now we have all of the coefficients and constant terms and even the remainder that's going to be a part of our final quotient. But we're just missing the variables, so we need to fill them in. I'm going to just take these numbers and copy them at the bottom so that we have a little more room to fill in the variables. Now I find it easiest that when we're filling in the variables that we start with the very last number and then work our way to the left. The very last number there isn't going to have a variable, that's actually our remainder. So we can put an R in front of that number. Then we work our way left to the positive 7. This is the constant term in our solution. So since it's the constant term, we don't need to write a variable with it. Then we can move over to the negative 8. This will be our first degree term. So we can write an x next to it with no exponent. And then when we go over to the 4, this becomes our second degree term, so we fill in an x squared. So our final answer is 4x squared minus 8x plus 7 with a remainder of negative 8. We could also write this answer showing the remainder as a fraction. And here's what it would look like. 4x squared minus 8x plus 7 plus negative 8 over x plus 2. The remainder becomes the numerator of the fraction and the divisor becomes the denominator. So here's our final answer, which we call the quotient, written both ways. So you just learned how to use synthetic division to divide polynomials. Great job!